Well, greetings everybody. So I got this question from MyMathLab yesterday, and I want to go through this in as straightforward of a way as I can, and I want to delineate steps and so on. I had already made another video about this, but I included more of the background information, okay, leading up to solving the problem. Whereas here, I'll just focus on the bare minimum to solve the problem. All right. So what I'm given here is that there's a population of some kind. There's a population mean. Sigma is the population standard deviation. A sample is taken. X bar is the mean of the sample, and n is the size of the sample. All right. And the question is to make a 90% confidence interval for the population mean. All right, now there's a definite procedure to this. There's not really any mystery as far as you having to figure out something different than what you see here. All right, so I'm going to go through it the way that it is. The way that you make this confidence interval is you take the sample mean, which is x bar, and you subtract this number e on the left end, where E is called the margin of error, and here's how you calculate it, and I'll go through how you calculate that in a minute. On the right end of the confidence interval, you take x bar and you add this number E, where again the number E is the same thing. Okay, and I'll tell you how to calculate E here in a second. All right, now when you look at this number E, this also called the margin of error, it involves sigma, which that's something we're given, and it's right there, and it involves the square root of the sample size, and that's also something we're given. And then the only number in here is z subscript c. That's not something we're going to have to figure that out. But with access to StatCrunch, it's not hard to figure it out. Okay, so ZC in fact is found on the standard normal distribution on StatCrunch. StatCrunch makes it very easy to find that. I'll have to show you exactly how you do that in the context of this question, but I'll go through it slowly and you'll see what I mean. Okay, so I'm going to build this interval, and so long as I know what this number E is, I'll have my answer. So it makes sense, I think, if I'm going to calculate this to start by finding the one number in here I don't know, which is ZC. Okay, so I'm going to find ZC. I'm going to open StatCrunch. All right, so here I have StatCrunch open, and I do calculators and I do normal. Okay, so here's my normal distribution calculator. In fact, you use the standard normal to do this. So that means that, well, the standard normal has a mean of 0 and a standard deviation of 1. And whenever you open the normal calculator on StatCrunch by default, it's the standard normal. It'll pop up by default with a mean of 0 and a standard deviation of 1. That's what we want. Now, here's how this number ZC is found on StatCrunch. Okay, do you see this number up here, C? That's the one number I haven't talked about. That's the level of confidence for the confidence interval. So the way that you find ZC is you want 90% of the area between symmetric bounds on the standard normal. And whatever numbers make that happen is going to be ZC. Okay, so let me show you what I mean by that. So see how C is 0.9. All right. So I set this to between, and if this was 90% of the area or 0.9 of the area, this number would be ZC and this would be its opposite. So the way that I figure out what that number is I put 0.9 right there. You know, whatever this given level of confidence is, that's what I put right there. Okay, so set it to between, you'll get an inequality, something less than or equal to x, less than or equal to something else. Set that to 0.9, set that to whatever you want, or whatever C is given to be, and then you just hit compute, so you get this number. So that number, or the opposite of this one, however you want to see it, you can just look at this one. That is the number ZC. 1.6449. Okay. All right, so ZC, I found the stat crunch, 1.6449. Okay, okay. Now, what's the rest of it? So remember when I said all you need is the margin of error. Okay, and what do you need to find that? Well, you need sigma, which you are given. You need root n, where you're also given n, and you need ZC. Well, we just figured out the ZC. So, all right, so here's my formula for the margin of error. The margin of error is the entire basis of how we construct the confidence interval. So there's my formula, and here are my values. ZC we just calculated to be 1.6649. There is sigma, given in the problem. N was 60, so I get root 60, and there's my number once calculated. Okay, so remember the confidence interval is x bar take away e on the left, x bar plus e on the right. This is e. What's x bar? Okay, x bar is 6.4. So what I do is I take 6.4 minus this, I get 6.29. And again, x bar 6.4 plus this, I get 6.51. In the question, it does say to round to 2 decimal places. Okay, so I'd have to, when I do that, I got all these decimals. I have to round that final answer to 2 decimal places, but that's how we do it. Okay, so hopefully this is broken down nice and easy into distinct steps. You find one number, okay, use that. You find another number, use that. You put the answer together. Okay, so you can go through it for any of these confidence intervals in this assignment just like that.